Hello, thank you for watching this video. So in this video, we're doing question 5 of May, June 2024 question paper mathematics paper 2. The topic is the trigonometry or trigonometric principles. So I'm going to read question 5 statements and then answer the questions that follow. So let's go. Question 5. 5.1. If sine 40 degrees is equal to P, write each of the following in terms of P, right? For example, at 5.1.1, you want to find or write sine 220 degrees in terms of P. No problem. So how do we approach this? The first thing that I would advise that you do, just draw a rough sketch of this situation here. You just say, draw yourself a small Cartesian plane here. 0 degrees, 90 degrees, 180 degrees, right? 270 degrees, 360 degrees, right? So 40 degrees is an acute angle. It's on the first quadrant, so it's here. Just draw a line like this and join it down here, such that this is 90 degrees. So that is your 40 degrees over there, this angle here. No problem. So you know very well that sine theta is expressed as opposite over hypotenuse, right? If you are working mostly on a right angle triangle, it's the opposite side over the hypotenuse side. So in that case, you are given sine 40 degrees to be P. So you are given that sine 40 degrees is equal to P. So your theta is your 40 degrees in this case. Your opposite, they say sine theta is called opposite over hypotenuse. So this P that you see there should also be opposite over hypotenuse, right? So let's say our opposite is P. What is our hypotenuse? Our hypotenuse should be 1. So that P over 1 remains unchanged. It's the same as P. So in this case, your opposite is P, your hypotenuse is 1. So if you're looking at 40 degrees here, the side opposite 40 degrees, which is that one, is your P, because, yeah, it's P. And this one down here is your hypotenuse, which is 1, the longest side of your triangle, right? And what we're missing now, you're missing this horizontal distance here, the x component of that triangle. So how do we get it? So okay, we can use Pythagoras theorem. Say r squared is equal to x squared plus y squared. What is your r squared? Your r squared represents your hypotenuse, so it's 1 all squared equal to x squared, which is the x component, plus your y component, which is what? Which is P. So you can solve for x in terms of P. So let's solve for x. So it's 1 is equal to x squared plus P squared. Transfers the P to this side, so you have 1 minus P squared is equal to x squared. Then take the square root, because it's a plus or minus. Therefore, your x is equal to this positive square root, because x is on this side. We know on the right hand side of 0, the x values here are positive. So it should be the positive 1 minus P all squared, which means the x component here is 1 minus P squared. So once you complete this triangle, it's easier to work with it. Also, now you can also find this angle up here and say, okay, if I add this 40 degrees, this 40 plus this 90 plus that angle there, let's say that angle there is beta, they will all add up to 180 degrees, because the sum of angles in a triangle are supplementary, right? Angles in a triangle, they add up to 180 degrees. So what do you have? So you have 130 plus beta is equal to 180 degrees. Transfers to 130 to the side, so your beta is equal to 50 degrees. So this angle up here is 50 degrees. Once you have this triangle fixed or fully filled, it doesn't. It will be much easier to express all of these in terms of P. Right? No problem. So let's come to this now. The first thing that you should do, you want to write this as an acute angle, right? So that it's either 50 or 40. so that you can be able to express it looking at that triangle over there. So try to write this sine 220 degrees as an acute angle. No problem. So where is sine 220 degrees? Our sine 220 degrees is more than 80 degrees, but less than 270. So it's somewhere here on the third quadrant. Right? So the values that are here are more than 180. All the values that are here are more than 180 because you are increasing in this direction, in the counterclockwise direction. So the angles that are here, you can say, okay, this sine 220 degrees is equal to sine of what? Of 180 degrees plus something, because it's more than 180. It's more than 180. Or you can say 270 minus something. It's up to you. So 180 degrees plus what? It's plus 40. Right? Then ask yourself some interesting question. Where is 180 degrees plus? 180 degrees on the third quadrant. First question done. What is the sign of this trig ratio there? What is the sign of sine in that quadrant? On that third quadrant. On this quadrant, sine is negative. So say what? Negative sine of that angle over there. So it's negative sine 40 degrees, which is equal to negative. What is sine of 40 degrees? Because this negative is this one. What is sine of 40 degrees? Go to a triangle and look for your sine of 40 degrees. Sine of 40 degrees is the opposite side over the hypotenuse side. So it's p over 1. So it's p over 1. Therefore, your sine 220 degrees is equal to negative p. We're done with this one. We move to the next one, which is 5.1.2. So they want you to write what? They want you to write cos squared 50 degrees. Right? In terms of p as well. No problem. So cos squared of 50 is the same thing as cos of 50 degrees all squared. This is the same thing. But it's just the way. This way is a much easier way and much neater way of writing it. It's a more nicer way and much cleaner way of writing it as compared to this one that have the brackets. So cos squared of 50 degrees is equal to cos squared is equal to cos of 50 degrees all squared. It's the same thing. Then now what we need to find is go and find this cos 50 degrees. Let's go and find it. Cos 50 degrees, here is 50 degrees here. Your cos of 50 degrees is the adjacent side, right? Because you know that cos theta is equal to the adjacent side over the hypotenuse side. So if you have 50 degrees, what is the adjacent side? Here is the adjacent side, is this side here. P over the hypotenuse side, which is 1. So what you're going to say is this is equal to P. Adjacent side of the triangle is P over 1 all squared. Therefore, your cos squared 50 degrees is equal to P squared. We're done with this one. We move to the next one, which is 5.1.3. What are they asking us to find? In 5.1.3, they want us to find cos of negative 80 degrees. That's what they want us to find. So, if you look at this, what we have in our triangle, we don't have a negative number there, right? It's only 40 and 50. So what you should try to do is make that number positive. How do you do that? You add 360 degrees to it. That's what we do. Let's do that. So we're going to say this is equal to cos negative 80 degrees plus 360 degrees. And this is equal to what? And this is equal to cos 280 degrees. That's what we have. This is the cos of 280 degrees. Where is cos of 280 degrees? Cos of 280 degrees is on the fourth quadrant. Because this is 280. You have 270 here, you have 360 there. So 280 is somewhere in between here on this quadrant. So what do? Express this as an acute angle as well. That's what you do. So this is equal to the cos of 360 minus 80 degrees. 300 is equal to the cos of 360 minus 80 degrees. That's what we have. That is what we have. So what do we do from here? So okay, we get that now our cos of negative 8, which is what we're given, right, is equal to this. It's equal to cos of 360 minus 80 degrees. Once you get here, you start asking yourself some questions. Where is 360 minus? 360 minus is on the third quadrant, right? No problem. Second question, what is the sign of cos there? On the fourth quadrant, cos is negative, right? So we have, so it's positive. So we have positive cos 80 degrees, just going to be cos of that. Like you have seen here, it was just a sign of this. And look here, or here, you didn't have to express that. So down here, it's going to be just a cosine of that. Then, if you look at it, you have cos of 80 degrees, but you don't have 80 degrees here. You don't have 80 degrees here. You only have 40 and 50. So, but you can see that this 80 is a double of 40. So you have a double angle there. So you have doubled your 40 and you got 80 degrees. So smaller you have cos of 2 times 40 degrees. Because 2 times 40 degrees is equal to 80. And then if you have this, you know that you have a compound angle in that case. Because you know cos of 2a is equal to what? Cos of 2a is equal to cos squared a minus sin squared a. Or is equal to 2 cos squared a minus 1. Or is 1 minus 2 sin squared a. That's your cos 2a. That's all you have. So check any of those. They will work. But I'll take this one because I have sine of 40 degrees already. So in that case, what I'll have, if I have cos 2 times a, which is 40 in this case, is equal to what? Equal to 1 minus 2 sine squared a. What is my a? My a is 40 degrees. So this is equal to 1 minus 2 sine squared a. What is your sine squared? What is actually, let me just say sine 40 all squared, right? Which is equal to 1 minus 2 into all squared. Go and find the sine 40 there. What is the sine 40? Sine 40 is the opposite over the hypotenuse, which is just p, which we were given in the first place. Just p. So, you can say p over 1, right? It's p over 1. So, your cos negative 80 is equal to the answer to this, which is 1 minus 2 p squared. So, this is how we conclude this question. And I think it is straightforward, as long as you understand these principles, right? And I hope it does make sense to you, as it does to me. So I'm going to clean the board and do the next question, which is 5.2. So let's go. Okay, so now we're doing 5.2, right? 5.2 reads as follows. Given that tan x times 1 minus cos squared x plus cos squared x is equal to sine x plus cos x times 1 minus sine x cos x all over cos x. So we're given this thing that you can see here. So they want, at 5.2.1, that's saying prove the identity. So they want you to prove that this side is equal to this side, or this side is equal to that side, right? No problem. So we want to prove this identity. You can pick this side and go there, or pick this side and come this side. So it's up to us how we do it. So for now, I'll say let's pick the left-hand side, right? This side here. And try to show that this left-hand side is equal to the right-hand side. So how are we going to do this? So okay, I'm trying to show that this side here is equal to the right-hand side. So, which is I'm picking tan into 1 minus cos squared x plus cos squared x. That's what I'm picking, right? No problem. So in this case, you know tan x, right? Tan x is equal to what? Tan x is equal to sin x over cos x times what? Times 1 minus cos squared x plus the cos squared x. Right? So this is similar to, or this is the same as sin x times 1 minus cos squared x all over cos x, right? Plus the cos squared x here. Right? But what is cos squared x? Because if you're looking at this and this, you're trying to make it look similar to these. So you want your sine x's as well, right? Maybe we can just express this part here, this cos squared x, because you know that sine squared x plus cos squared x is equal to 1, right? So if you have cos squared x, you can solve your cos squared x here and transpose this to the other side. So cos squared x is equal to 1 minus sine squared x. So in this case, where you see a cos squared x, you can put that identity over there, which is 1 minus sine squared x here. Right? No problem. This is over 1, just add these two over 1. So the lowest common denominator is this time this, which is just cos x. Right? No problem. So this times that, so it becomes sine x into 1 minus cos squared x plus this times that, which is cos x into 1 minus sine squared x. That's what you have, right? No problem. So what do we do from here? You can just multiply the bracket out and say, okay, this times this, so this is sine x, sine times cos squared x minus sine x cos squared x plus cos times x, that's cos x, cos times sine squared x, that's minus cos x times sine squared x, all divided by what? All divided by cos x, of course. No problem. So if you look at this and this, there are similarities. For example, your sine x times 1, you get sine x. So here is sine x here, right? The sine x times that, you get minus sine squared x cos x. Minus sine squared x cos x is this one here. Because if you multiply sine x and sine x times sine x times sine squared x, sine x times sine x cos x, it will be sine squared x cos x, which is this. Look, cos x times 1, you get cos x, which is this one here. Say cos x times sine x cos x, it will be sine x cos squared x, which is what you have here. So this is exactly that, but that one is factorized and this one is not. So what we're left to do is just to factorize this part so that it goes back to that. So let's do that. How are we going to do this? So let's just group these two together. It's the simple ones. This cos x and sine x. So we have maybe sine x plus cos x, right? Minus, so you have grouped this one and this one. Minus this, which is minus sine x cos squared x minus cos x sine squared x, right? No problem. So what do? Let's take sine x cos x cos x as a common factor out here. So what you have, so this is all over cos x, of course, sorry. So let's take sine x and cos x as common factor on both of these sides. So you have your sine x plus cos x, which is this part here, minus, take sine x as a common factor and cos x. So if you take sine x and cos as a common factor, you'll be left with cos x here. So you will have sine x times cos x into, here you'll be left with what? With just cos x. Minus, down here, you're taking sine x and cos x as well. You'll be just left with a what? With the sine x there as well. This is all over cos x. And then look at this, look at that. So this is a common factor on this upper fraction up on the denominator. Sorry, on your numerator. On your numerator, this is a common factor. So take this out as a common factor. So which is the common factor is what? Is sine x plus cos x, right? Then if you take it out, you're left with 1 here. Minus just this. Sine x times cos x. All divided by what? All divided by cos x. So this is equal to the right hand side. Because the right hand side was this. So this is equal to that. And we're done here. We're done here. Or maybe, let's see what happens if you take, maybe if you choose the right hand side. Let's try to choose the right hand side and see how far we'll go. If you choose the right hand side, we're choosing this side here. So we're trying to make it look like that side. So in this case, I'm choosing the right hand side, right? So on the right hand side, I have what? I have sine x plus cos x, right? Times 1 minus sine x times cos x all over cos x. So what do we do from here? Because I've chosen the right hand side now, we're trying to prove that this is equal to that. So let's multiply this bracket out. Let's expand this. So it's going to be this times this. So we're going to get sine x times that minus sine squared x maybe cos x. This time this plus cos x. This times that minus maybe sine x times cos squared x. I'm going to clean this part. That's what we have. Of course, this is all over your cos x. That's what we have here. So look, now cos x divides all of those things on top there, right? So which means what we have, which means we have cos x divide all of those things that are on the numerator up here. So which means we have sine x, which is this over cos x. We have this minus sine squared x times cos x all over cos x here, right? No problem. We have plus cos x over cos x, right? And we have minus sine x times cos squared x all over cos x. This is what we have so far, because this cos x divides all of those things that we have up there. So what is this? This is what you can see here. What you can see here is tan x, what you can see there. This is the tangent of x. Minus what? So say this and that go away. What are we left with? We are left with sine squared x cos x or cos x, that's plus 1, right? And then now, if you can see here, look at this. If you multiply this and this, you have tan x, this you have tan x cos squared x. So what I would not want us to do, I would not want us to get rid of this tan x, I would not want us to cancel this cos x and that cos x up there, because we should be having two tans, as you can see here, because say this times this is tan x, this time this minus tan x, cos squared x. So there should be another tan x that goes with the cos squared, right? So if you're looking up here, this is tan x that goes with it. This is the tan x here. This tan x over cos x is the tan x that goes with the cos squared, as you can see over there. So what do? You say here minus tan x, because this over this is tan x, times cos squared x. So you group this and that together. What do you have? Say, okay, I have tan x minus tan x cos squared x, right? Plus 1, which is this, minus sine squared x. Right? Then take your tan as a common factor. So your tan x go out and you're left here with 1 minus cos squared x. What is this? 1 minus sine squared x. 1 minus sine squared, that is cos squared x. So we should have plus cos squared x, which I think should look or is the same as this one here. Right? So this is equal to what? Your left hand side. So any of these two ways could have worked. So I'm going to 5.2 now. We're done with 5.1. 5.2.2. We're done with 5.2.1. Or maybe, let me not clean this part. So we're going to 5.2.2. At 5.2.2, they are asking for which values of x in the interval from minus 180 degrees to positive 180 degrees will the values of x be undefined. Actually, for which values of x on the given interval that you will see will this expression be undefined. So they're asking for what values of x will this expression here, which is the same as that, be undefined. What does it mean to be undefined? It means you don't have a value at a specific point. For which points or for what values of x will you not have a value on this thing? So most fractions or most fraction expressions or rational fractions, if you are dealing with algebra, these things are undefined if the lower part is equal to 0. So if you get your cos x is equal to 0, then this expression will be undefined because you'll be dividing by 0. So if this whole part is 0, then this expression will be undefined. Right? Which means the first condition, your cosine of x should be equal to 0 if you want this thing to be undefined. Then go and find those specific values of x which give you cosine of x being 0. So the next thing that we're going to do to find the actual values of x, that sends us to the cosine of x being 0. So what do we do? So x is equal to, take the cos of both sides. Arc cos of 0, your x is equal to plus or minus 90 degrees. So for x is equal to 90 or negative 90, this part here is equal to 0. So if you substitute 90 or minus 90, the answer, this will be 0. The answer to the entire, if you substitute your x is 0 there, if you substitute your 90, x is 90 there, the answer that you will get will be equal to 0. Right? Same thing if you substitute to minus 90. Cos of 90 times 90 is also 0. But then now, if you substitute cos 90 on this expression, or that one all over there, the answer will just say undefined or math error on your calculator if you're using the Casio calculator as me. So, cosine of x is equal to 0 if x is equal to plus or minus 90 degrees on that given interval, which is what? For x is an element of minus 180 degrees to positive 180 degrees. We're done with 5.2. So I'm going to clean the board and we do 5.3. So let's go. Okay, so now we're doing 5.3. 5.3 reads as follows. Given the expression sine 150 degrees plus cos squared x minus 1 all over 2. So you're given this expression here, which is sine 150 degrees. So this should be 150. Sine 150. Sine 150 degrees plus cos squared x minus 1 all over 2. So at 5.3.1, what are they saying? At 5.3.1. At 5.3.1, they are saying, without using a calculator, simplify the expression above to a single trigonometric term in terms of cos 2x. So they want us to simplify this thing into a single trigonometric ratio in terms of sine 2x. What do we do first? First, reduce this to an acute angle. So, say, okay, sine 150. Where is 150 degrees? 150 degrees is on the second quadrant, right? So, this is equal to sine 180 minus 30 degrees. This plus cos squared x minus 1, right? All over 2. Then ask yourself, where is 180 minus second quadrant? What sign is sign there? It's positive. Just put your sign there, positive. Then just take the sine of 30 degrees. So sine of 30 degrees plus cos squared x minus 1 all over 2. So what is sine of 30 degrees? Sine of 30 degrees then is a special angle. So sine of 30 degrees is equal to a half. So it's half. It's a half plus cos squared. Cos squared is a half, right? Plus cos squared x minus 1 all over 2. That's what you have. So what do we do? This and that are like terms. You add them. So we are left with cos squared x half plus negative 1. That will be a negative half all over 2. That's what we're left with. Right? So we can add these two, simplify at the top. So what do we have at the top? So what we have at the top is cos squared x minus what? Minus a half divided by 2, which is this 2 here. So this is this part in the bracket. Over 2 is that. Fine. Let's deal with what is inside here. So it's all over 2, which is what we have in here in the bracket. So it's over 1, this one. This time this loss common denominator is 2. This time that you are left with 2 cos squared x 1 times 1 minus 1 divided by 2, right? So this is a double angle identity, right? So 2 cos squared x minus 1 is what? Is cos 2x all over 2, which is this, divided by 2, right? So you can change this to a multiplication sign. So you have cos 2x over 2 times 1 over 2. So this is equal to what? Cos 2x over 4. That's what you have. So this is the simplest form of this identity. Or maybe this is where they want you to stop with it. So you're done here. We go to the last one, which is 5.3.2. They are saying now, hence determine the general solution of this thing, right, is equal to 1 over 25. So they want us to find the general solution. So this is 5.3.2. They want us to find the general solution of this thing here, which is sine 150 degrees plus cos squared x minus 1 all over 2, right, is equal to 1 over 25. So they want us to find the general solution of this thing here. But we already simplified this part here. This part is this part here. So instead of writing this, we can just write that straight away. So cos 2x is equal to 1 over 25. That's what we have. Cos 2x over 4, in fact, because that's what we have. It's equal to 1 over 25. Then we solve for cos x, cross multiply. Don't even have to cross multiply by 4. Multiply by 4. This and that go away. Your cos 2x is equal to 4 over 25. Right? No problem. Then what we need to do is just to find the reference angle. Right? So, the reference angle will be equal to your cos arc of 4 over 25. Which is, what is what? What is it? Then let's punch that and see what we get. Arc cos of 4 over 25 is equal to 80.79. So that's our reference angle. And we're going to find solutions where our cos is positive. Cos is positive where? On the first quadrant and in the fourth quadrant. That's where cos is positive. So the first solution of the first quadrant will be that. So you say, okay, not just x, your 2x is equal to what? 80.79 plus k360. So divide by 2, divide by 2, divide by 2. And your k is an integer, of course. So we get that your x is equal to half of that. What is it? It's 40.40, right? Plus 180k, where the k is an integer, right? This is the first solution, which is from the first quadrant. From the third quadrant, or from the fourth quadrant, your 2x, which is this, is equal to 360 minus your reference angle, which was 80.79 plus k 360. So you divide by 2x, divide by 2x, divide by 2x. Okay, that your x is equal to. Go and find the answer to that. So you say 360 minus this, and then divide by 2. So you get that this is equal to 139.60 plus k 180 or 180k. And I said before, your k is an integer, which is can be any of these 1, plus minus 1, plus minus 2, and so on. And we're done here. And I hope this does make sense to you, as it does to me. Thank you for watching. Cheers.